Okay, so we'll talk about the SQL Basics in this lecture. SQL Basics can provide you with some basic information about SQL this language, and you can also learn how to use SQL to perform some queries in your database systems. So it's a good time for you to practice the SQL we learned from the lectures. And before we start this section, you may also wonder why we need to have SQL and why we have to learn this. It can provide you with some notifications to learn this SQL this section very well. Formally, this SQL stands for the Structured Query Language, and in some other sites, it also stands for the Standard Query Language. It doesn't matter. The name doesn't matter. You can understand in either way. It is initially developed by IBM by the download as well Raymond in the early 1970s. It is also initially called SQL, the Structured English Query Language, or the SEQL. And later on, we changed the name to SQL instead. It is shorter. And there actually exist different versions of SQL. We have SQL 92, SQL 3, SQL 99, and SQL 2011. Actually, the standards has been changing with time because we need to develop or implement some new functions in SQL. It is still evolving with time, and then we may have some new versions of SQL as well. For the SQL, we have different versions, and the vendors may support different subsets of these standards. In other words, when we try to implement or test the SQL queries we learn in the lectures, when we implement them in the database systems in your software on your computer, you may have some problems because some of this grammar or some standards can be different from the standards of your database software. So therefore, when you are running the SQL queries we cover in the lectures on your computer, you need to check your software, the database software carefully to see the standards of your SQL versions supported by your software. Okay, and you also wonder why we need to learn SQL. So SQL is very different from C++ or Java. It is a very high-level language. It just describes some of these functions we plan to implement. However, we never touch the details of its implementation. In this way, it provides us with this high-level thinking about queries instead of this low-level like implementation details. So SQL provides grammars to avoid satisfying and also data manipulation details that would be necessary in language like C++. Also, SQL is optimized in certain sense. The queries are optimized in SQL very well. It can also improve the efficiency of these query executions on your system. So that's the reason why we need to learn SQL in this section. It allows us to do some high-level queries, and it also helps us to optimize the queries we plan to perform to improve the efficiency. If you still remember, in the introduction section, we mentioned we have two different languages in database systems. The first one is called DDL. If you still remember, the DDL stands for Data Definition Language, right? DDL mainly focus or deal with the schemas or the relations. We can create some relations or tables with DDL. And in SQL, we support the DDL as well by creating some functions there. For example, we can create a new relation or new schema by creating a table instead in the DDL supported by the SQL. For example, we can create a table with a table name provided. We also need to illustrate all the attributes or the columns, both the names as well as data types. And sometimes we also need to include some of the constraints like the keys, right? What is the key for the table? We may also include some other table constraints and reference to some other foreign keys in other tables as well. So in SQL, we can create tables, and this actually is the DDL functions we can use in SQL. If you still remember, besides DDL, we have another language. It is called DML. DML stands for Data Manipulation Language. Generally, DML mainly deal with data tuples we plan to handle in our applications. Now we can implement some queries by using the DML to get some data or process some data we have. And SQL also supports the DML. So generally we can write the DML in a standard format. The standard format is like this. We have select from where. Almost all the queries we need to write later, they will be in this format. Select something from some of the relation where with some conditions. Select from where there are 3 reserved words or keywords by SQL, and each one will lead a clause in this queries. So we have select something from some relation or table and where followed by some conditions. We will show the examples later. Okay, let's talk about the select from where statements in depth. So formally, when we write queries in SQL, the queries format we plan to write will be like this. We have select some desired attributes from one or more tables where conditions about the tuples or tables. So select from where there are 3 reserved keywords, and we prefer to write them in the uppercase, select from where, and they are followed by a clause. Select is followed by some desired attributes. From is followed by one or more tables. Where is followed by some conditions about tuples or tables. So all the queries we will write later on data manipulation will be like this. Select some attributes from some tables where is the condition. So if you still remember, we have studied this in the relational algebra before, right? If we plan to rewrite this, if we want to know what does this mean, actually we can first write the relational algebra expression about this statements instead. Then you should be able to know what we are doing by writing the select from where statement as shown here. So formally, let's assume we are working on a relation R, and the select from where statements we showed before actually denotes what? Select some desired attributes from one or more relation where is a condition. Actually, it denotes what? So you need to pay attention here. We have a keyword select, and it is followed by some desired attributes. Even though we write select here, actually this denotes the projection we learned before, right? So therefore, this statement actually denotes projection, right? Projection, we want to project some desired attributes, right? Therefore, we need to copy the desired attributes here. We're doing a projection here. Let me change this font size to the subscript. So we're doing projection, project some desired attributes, right? And inside it, we're working on what? We're working on a relation or a table, right? However, here we have some conditions for the tuples inside the table. Therefore, inside a projection, this operation, we're working on another operation. It is doing the selection, right? We're selecting some condition, right? And this condition denotes the condition we describe in a where clause, right? Inside we do a selection some condition, and we are working on a relation R, right? So therefore, this select from where this statements actually denotes we're doing projection of some desired attributes, and which relation we're working on this R. However, we have some condition for data tuples. Therefore, we have a selection with some condition as shown here, right? So actually, this relational algebra expression can be denoted by the select from where statements as we show here. I hope you can follow me, right? So this select, even though it is select, actually this one denotes a projection. We project some desired attributes. This from denotes the relation or table we're working on. It denotes the target relation we're working on, right? And where is some condition, and we are doing a selection for the where clause. We have selection with some condition on the relation R we are working on. So we do the selection first and do the projection of the desired attributes. I hope you can follow me, right? this is select from where statements we will write in the SQL. So you should know this. This select is a projection of some attributes, and this where denotes some conditions. We need to do the selection in the relational algebra. So when you are studying in this section, I hope you can write down the relational algebra expression first, and then you can translate this relational algebra expression into the select from where statements. It will be very helpful for you in the very beginning. It can help you to follow the ideas for this queries. And later on, as you are getting familiar with the select from where statements, you can write down them directly, and you don't need to write down these relational algebra expressions. So, and I also need to make some comments on this select from where statements. Normally, we need to follow the template as shown here, select some attributes from some tables where with conditions. However, when we write it, normally we have a semicolon after it, denoting it is the end for the statement. The semicolon is usually necessary and required as a grammar requirement for the SQL queries, so don't forget the semicolons. And for some queries, if we don't have any conditions, this where clause can actually be removed. You may see some SQL queries without this where clause. We only have select some desired attributes from some tables, and we can finish without this where clause. If we can see some queries like this denotes actually we're doing a projection of some relation, right? We don't have any conditions anymore. If we see a query like this, select from, it equals to what? It equals to a projection of some desired attributes from some relations, right? So normally for the select from where statements, we need to have select, we need to have from, and this where can be optional depending on the requirements and the questions. Okay, so that's it for the select from where statements. In this section, we also show lots of examples, and here we assume we are working on a relations as shown in this page. I mean, the diagram is like this. We assume we have three entities: the beers, the bars, and drinkers, and they each have some attributes: a name, manufacturer for beers, as well as a name, address, and license for bars, and a name, address, phone number for drinkers. Among them, they have some relations. Between beers and the drinkers, we have this likes, denoting this drinker likes a beer. Between the bar and the beers, we have sales, and also have one attribute price, denoting this bar sell the beer with some price. And between the bars and the drinkers, we have frequency, denoting this drinker go to this bar very often. And in the following slides, we assume we are working on some data like this. And based on the knowledge we learned before, right, we can translate this ER model, ER diagram into some relations. And we translated this ER diagram into 6 relations, if you still remember the translation rules, right? For the entities, beers, bars, and drinkers, we can create a relation of beers with name, manufacturer, name is the key, bar with name, address, license, name is the key, and drinkers, name, address, phone number, and name is the key. And we can also translate the relationship into a relation as well. Now we have likes between the drinker and the beer, as well as sales between bar and the beer with some price, and frequency between the drinker and the bar. So we can translate everything into relations, right? These underlying attributes denote the keys for the relations. Furthermore, based on relations, according to our previous knowledge, we should be able to create some tables for it in our database systems, right? So we can create some tables. Now we can create a table for beers with name, child 64, as well as manufacturer 64 as child as well. And this name is a primary key. It will be similar for the bars and drinkers. We can also create a table for them, right? The name are the keys for these tables. In a similar way, we can also create tables for the relationships we showed before. We can create a table for likes between the drinker and the beer. So we can create a table likes, drinker, beer, their child 64. We're going to set the primary key of this relation of this table to be the drinker and the beer combined together. So here the drinker and the beer, they are the foreign keys, right? So we have a foreign key drinker reference to drinkers, and foreign key beer reference to beers. In a similar way, we can also create tables for sales and frequency. So these are the relations we will be working on in the following slides as examples. So you just need to remember we have like 6 tables. And in the following slide, we can just show you some queries working on these tables. And we will not mention again what the tables are like, and you can also check back to these 2 pages when we're discussing about queries in the following slides. Okay, so based on these tables, we can create or we can write down some standard from where statements as shown here. Here, let's assume we have a question. Given the beers, this table, and we will find what beers are made by Bush. Bush is a manufacturer, and we plan to find the beer names which are made by Bush. So before we showing the standard from where this statement, I hope you still remember we can write down this query with the relational algebra, right? And we plan to find the names of the beers, right? Therefore, we are doing the projection of name, and we have some condition here. We do projection name and selection manufacturer equals to Bush, and we're working on the beers, this table, right? So when we translate this expression, the relational algebra expression into select from where statements, we can write down the query as like this. We select the name, beer name, right? From beers is a table where manufacturer equals to Bush. Bush is a string, and we're matching the manufacturer with Bush string, and followed by a semicolon denoting the end of this statement. In this way, we're able to find all the beer names which are made by Bush, and we can show the returning result as on the right hand side. The returning result will be a table. However, this table only has one single attribute, is a name, because we're doing the select name, right? We do a projection of name only. We have one single attribute, one column, and inside it, there are all the beer names made by Bush. For example, we have Bud Light, and another beer as shown here. So this is about select from where this statement. So the result is still a relation or a table with one single attribute, the beer name, and tuples with the name of each beer are made by Bush, such as Bud as shown here, right? So this is an example. And besides this, I also need to reinstate. We use so many examples on beers in the lectures. However, we are not promoting the beers or drinking to the students. If you don't drink, then it will be very good, and you don't have to drink beers. We just use these beers as an example for you, right? And personally, I don't drink neither. However, I think it will be very interesting to use beers as an example for delivering these lectures on database systems. Okay, this is about the select from where statements.